So I've started the recording, and I'd like to welcome everyone to the Mel Foster Seminar Series. Today we're presenting TTM technologies and their RF and thermal solutions for your design challenges. Everyone, I unfortunately can't mute everyone, but if you would all just mute yourselves during the presentation, that would be appreciated. And then you can direct any questions along the way to your chat feature. And I'm actually going to send a quick poll so that everyone can see where your chat functions are. So if you wouldn't mind, just make sure everybody has access. Great. So during the presentation, Ryan Julie, Director of Regional Sales, will be monitoring the questions, and we'll have about 10 minutes at the end of the presentation for answers. So this whole presentation will be about 30 minutes. I would also now like to introduce you to your presenter, who is Mark Bauer, Director of Business Development for TTM. He has 38 years of experience with RF and microwave industry and designs, and I'd like to turn it over to you, Mark.
Great, and thank you very much. And I appreciate the time everybody's spending on this particular presentation. I appreciate the fact that time is very valuable, and that your interest in this presentation, I hope, will be returned with some interesting facts and understandings of our capabilities. And as we go through this, I want to make it clear that due to time, I will be going through the slides at a unusually rapid rate. And if there's any subject matter that you see of specific interest to you, please reach out to us in the chat or separately after the meeting, and we can arrange additional meetings where we can take a deeper dive technically into these products and the technology supported by the RF&S business group here in Syracuse, New York. So first of all, let's have a quick overview of who we are. Many of you on the call will know us as Anaren Microwave, the near 60-year-old RF and microwave specialist component and subsystem company acquired by TTM in 2018. The objective of that purchase was to enable TTM to align with its customers in the engineering, development, and design phase, to enable us to get early access and help guide our customers with appropriately performing or priced products for the end application required. Our group, after acquisition, falls under the RF and Specialty Component Group, and that group is resident within the commercial group of TTM. So we have a space and defense group here, automotive, medical, industrial, communications, computing, and RF and specialty components are in a separate group to the aerospace and defense group. Most of the other numbers down here, I want to draw your attention to the key data point, and that is that the RF&S business group has manufactured and shipped over near 2 billion surface mount components now over the 28 years that we've been developing and supplying these commercial-based components in the RF space. And we continue to do developments, smaller sizes, higher performances, more cost-effective, and specialist components being developed for a variety of applications, not just in 5G and the cellular infrastructure space, but broadening that out into the broader communications market. And you'll see more of that as we go through the presentation. Our core strategy is to provide highly innovative engineering solutions and really create that competitive advantage for our customers. That's the main point here. Make your product better, make it more appealing to your end customer to win larger opportunities for you with the work that we're doing in our engineering side. We have our engineering and manufacturing in Syracuse, New York, and our ceramics team, that's our termination resistors, and our etch thick film capability is out of our Suzhou facility in China. Both those facilities report into RF&S's leadership team in Syracuse, New York. The next slide I want to touch on just briefly is looking at where we're spending our time development-wise. And this slide really shows off areas of our expertise, and it probably gives away a broadest nature of our product development and technology innovation. If we look on the bottom, the bedrock of all of our business is the standard components. We put 5G in here because that's just the sexy buzzword today. But standard components is the broad range of components from 100 megahertz to now around 40 gigahertz. And we're stretching out with components into the 77 or 76 to 81 gigahertz market for automotive radar applications as well, looking at innovative architectures to overcome some of the shortcomings of automotive radar as we move forward. And we'll touch on that again in a second. Our standard components range across most of the standard passive RF building blocks. So whether it's a coupler or it's a directional coupler, power dividers, baluns, any of these products that solve complicated electromechanical or electromagnetic challenges are the products that we develop using the material set that we do to deliver to our customers quality, high reliability, and repeatable products. And to the extent of the 2 billion that I mentioned in the previous slide. A new area for us since our acquisition and our exposure to the extensive capabilities inside TTM's printed circuit board fabrication capability is starting to look at problems that are resident next to our components. How do we manipulate the environment around our components to create more efficient designs, especially from a thermal perspective? And we can touch on that again as we go through this presentation. But ultimately, our amplifier module business using what we refer to as ETS, which is engineered thermal solutions, brings a new dimension of instigating thermal channels in printed circuit boards around and under heat generating components in a more cost-effective manner that drives more imaginative board layouts and more imaginative architectures in implementing high power components. And this has been applied in a number of different industries, from the industry of power modules in 5G right the way through to thermal management challenges that exist in a wide variety of communications environments, as well as power requirements where GaN is used in power supplies, where thermal management is a critical element of those product designs. That ETS engineered solution really lends itself mostly to high frequency applications, although the sub 6 gigahertz arena is a heavy focused area for us. It really brings it into its own with geometries of RF traces and ground planes as it pertains to X-band and higher frequency applications, where sensitivity of those geometries is a critical part of both yield and product performance. Also on our advanced device packaging, this is really taking our material set and our approach and moving that device packaging over to look at the photonics industry, where we're seeing a range of new architectures that are leveraging non-LTCC, HTCC packaging approaches for both cost and engineering timeframe perspective, and implementing this advanced packaging solution by marrying together ceramics as well as softboard materials so we can manage high-speed RF level signals on laminate material, but then use the mechanical and thermal properties of the ceramic as used in a mixed material packaging approach. This has been seen as very popular with our customers for both fast turn time in development, as well as implementing replacements for, as I mentioned earlier, LTCC and HTC ceramic approaches. Our millimeter wave components are really leveraging capabilities and technologies that we learned about in the printed circuit board side. We put 110 gigahertz test facility in Syracuse, which enabled us to start experimenting and developing products up to 110 gigahertz in a variety of focused applications. And our parts today are small crossover components that enable a coaxial feed through in a mixed material millimeter wave board to jump across the ring of ground vias to enable a low loss and short distance connection to feed networks that are placed on high cost material, which is on the transmitting side of the millimeter wave radar antenna design itself. This is a new and novel area for us where we're seeing significant success and traction as people are looking to move their radar ICs to the back side of the board for both thermal management reasons and packaging reasons, and then coming through the board, and that's a mixed material board, FR4 and high-performing material like Astra MT77 or Rogers 3000 series material, and to create a repeatable coaxial via in a low-cost manner. So the radiating element part of the radar is dedicated to that function, where currently high-frequency ICs are mounted on that high-performance material, and they require additional shielding that can impact antenna patterns, depending on the end application. And then finally, a new area that we had invested in 2007 by buying a company in New Jersey that was a ferrite isolator and circulator company. And we had been very successful out to 2009 when overpowering cost pressures from Chinese suppliers drove us out of the market in the commercial side. We retained our expertise in aerospace and defense, but more recently have come back to the table with a highly innovative packaging approach to create surface mount circulators in tiny form factors with high performances that are effectively caseless. So we're using a technique that delivers an 8mm square by 0.7mm high, 6mm high puck that looks more like a vitamin pill than it does a traditional isolator, and is married with circulator, sorry, and if married with a resistor, also an isolator. But this is a very new area for us, and we're going to be releasing samples of these products imminently, but it is in the 3.5 gigahertz and 2.5 gigahertz frequency range for this particular innovation. So this is the area that we have been spending the bulk of our time in developing and investing in internal engineering. And as we go through the next few slides, we're going to show you our traditional market and the traditional components that we provide to that market by way of using block diagrams to indicate locations of our components in a standard communications transmit lineup or receive lineup. And in this particular case, you can see our couplers and resistors are used extensively in the PA lineup. I think we have a relatively, if not a very high market share after many years of perfecting this technology, from powers that range in many hundreds of watts CW to many hundreds of milliwatts CW, with peak powers normally about 10 times our CW figures, allowing extremely small form factor parts to operate at outlandish high powers for their form factor, as I mentioned earlier. Our Ballon product range has been more aligned with RF transceiver ICs, as we see those transceiver ICs with differential outputs and inputs. They're using our low-loss Ballons, interfacing to those components. And a critical part of our product portfolio, which is important to remind everyone, is we do not use the conventional ceramic material set for our products. All of our products are built in a variety of different high-performance laminate material. In doing so, our CTEs are matching the boards they're mounted on. And this is giving our customers significant performance advantages by matching both CTE and also making those parts more of a synergistic part of their design, where ceramic parts can exhibit a number of failure mechanisms based upon temperature of operation and performance of operation requirements. Our couplers are normally in the LNA sections of our customers' designs. More recently, it's fair to say that these are highly integrated, balanced LNAs in QFN packages from a number of the semiconductor guys. But historically, they've been discrete front-end devices, which have been separated with 3dB hybrids to create a balanced receiver configuration in a standard superhet design. In this next design, we dive in deeper. And in diving in deeper, we look at where these products are used in the standard communications lineup. Again, we default mostly to the cellular infrastructure market, and that infrastructure market is a key growth engine for us and has been for 20 years. And we see our parts being used before pre-drivers, drivers, as well as the main output stages. We provide integrated Doherty components that can go on the output of a given customer design, directional couplers, power terminations required in every one of these slots, and now incorporating that all-important surface mount circulator as the next step as we look at block diagrams of conventional transmit-receive lineups, which we see pretty much similarity across the entire market. No one's doing anything extraordinary out there to the best of our knowledge, especially not in delivering end solutions to the cellular infrastructure industry. And on the right-hand side, we have PA modules, where we're seeing a lot of that driver and output stage now being integrated into a surface mount component. But then we see the pre-driver on the outside, but again, couplers, power terminations, as well as a number of other key technologies are also being developed by us, including high frequency filters. We have touched on filters many times over the years. We've stayed away from them under 6 gigahertz. The cues of our materials in our inability to produce high enough value capacitor and inductor elements within inside this material set has meant that our cues demonstrate relatively low performing filters, especially for bandpass filters, although we're better at low pass and high pass filters. But at high frequency, it's a complete opposite. We have this significantly high performance, exceptionally low cost filters, especially in the 27 to 47 gigahertz region, again, mostly for 5G, but also for some military and industrial applications that stretch from X-band to 50 gigahertz. So our standard components here from our legacy Zingers, the Zinger brand is something we created some 25 years ago, and that product is still going strong today and is the benchmark in branding of all of our products. In production today, our sub-6 gigahertz products are aimed at low power as we continue to see the output power per segment being divided up with various different technology needs, including massive MIMO. We see smaller and smaller needs for power. So our product and key functions are reducing in size both and in power, but trying to retain insertion loss to create the highest efficiency designs. Our ATO product in 0805s, and we have a unique 0805 footprint with a crossbar across the center of the device, which enables for a better thermal interface to a design or to a board. And that's seen in the image here under in production. And those parts now are 5 watt CW, 50 watt power handling for a component measuring only a matter of millimeters in size. So this has been a special area for us in product development. In pre-production, we're going down in size again, 0603, meeting the needs of our power module development partners. We're also now reviewing 0402 as a target device for true 3dB hybrid couplers. Our main focus here, both in terminations and couplers, is to get the size down. And as you can imagine, when we get down to these small sizes, you're talking about physical electrical length being included or created in such a way, in such a small outline package to meet the performance of the frequency need and overall insertion loss need of the customer while maintaining good phase and amplitude balance. These technologies are something we're working on every day. And today we have a range of 0404, 1 millimeter square parts, and we have a full range of 0603, both narrowband and wideband parts. And as we look into the future, we're spending more of our time on millimeter wave, in filter development, bandpass filters, power dividers, also as attenuators, and looking at attenuators in various values at high frequency. And we're about to release a DC to 81 gigahertz termination resistor in a surface mount package, which is proving highly interesting to the test and measurement industry, where they're trying to terminate output ports and input ports of device under tests. And today they use a variety of extremely expensive connectorized product, but moving to a extremely cost-effective surface mount may be the way forward for lower cost test and measurement and ATE applications. And our future products is really based on customer collaboration, working with our customers on the development of new parts that slot in between this 100 megahertz to 40 gigahertz spectrum and pick out passive functions at certain frequencies that are showing growth and opportunity in the emerging market space. So these families of products are outlined here as couplers, power dividers, and attenuators. New products I mentioned earlier, this slide deck will be available for everyone to see. It's really given you a complete portfolio of capability. In the last couple of minutes here I want to touch on this thermal technology. And this thermal technology ultimately is trying to break the cycle of coins and via farms being used as the appropriate approach for thermal management. And in this slide, you'll see on the left-hand side at the bottom a standard via farm, which is just not cutting it, as we see more and more introduction of gallium nitride as a core material, which has power densities that just are not suited well to poor thermal conductance within the printed circuit board for thermal management. In the center here, you see a traditional coin. Coins bring with them a number of challenges, whether they're pushed in or whether they're encapsulated within the board itself. The ground connection to the coin can be a significant challenge and force the use of microvias and various other methods of using prepreg to lock the coin in place so as to get the repeatable performance required, especially at higher frequencies. Under 6 gigahertz, debatable. Over X band and 10 gigahertz, absolutely required for consistency and yield in designs at higher frequencies. And on the right-hand side is a cross-section of our ETS capability, where in this case, we've implemented a T-coin. You can see M2 and M3 ground layers with perfect T connections without any additional vias used. And then we have on top our RF trace and how that trace feeds into that thermal region based upon the component being mounted, IC, whether it's chip and wire bonded, whether it's a QFN package, etc. And then in the next slide, you'll see those advantages are significant when it comes to board layout, and also enables you to take signal traces through the thermal region by reducing the size of the thermal location under the heat generating part of the device, which enables you to be more imaginative in the way the boards are designed, less layer count for routing reasons, and smaller overall form factors. In the case of this particular image here, 15% of the thermal area was utilized to create 96% of the thermal performance that was being achieved with what we believe is the control technology today, which is coins. And the other part of our technology that's interesting is our ability to go to different shapes. We're not locked into rectangles and circles. We can actually look at a wide variety of exotic shapes which meet the thermal profile of our customers' heat dissipation based upon whatever the devices they're mounting and whatever interface that is being mounted to. Because ultimately, this is a thermal sandwich, and understanding the CTEs between those sandwich layers is a critical part of thermal design in these modern high-density applications. We talked earlier and touched on our legacy thermal, as we've seen with coins, and as we go through phase 1, phase 2, we're working on the technology to 25 mil thicknesses. We're moving on to 40 mil, and we're hoping to get to 60 mil in time, being a 1.5 millimeter thick boards that this technology can be applied to. Our process engineering team is super comfortable to 0.65 millimeters, but as we move forward, as we get thicker, we are experimenting with new chemistries that enable the plating process to create a void-free and super flat environment for mounting devices on in this thermal space. Here we have a case study, and I've got about a minute left here, a case study that we looked at where we took that same technology, we looked at a die, we found that it had 5 or 6 heat generating locations. One of them was larger than the rest, and we applied ETS to those very specific focused areas to create this 15% of the volume, 96% of the performance. And that's outlined here by our thermal modeling. And again, as a component developer, our goal is to create high reliability and high repeatability through engineering thermal analysis, as well as our own simulation capability before committing to a real build. So what TTM brings to the table today goes way beyond their capabilities in the past, and that is working with our customers to create virtual concepts of ideas before committing to a hardware build. And having our business group in the loop has enabled us to work with our customers to develop a solution and then take care of DFMs and just deliver an end solution of a board with the technology in. So in summary, market-leading results, the technology goals were exceeded for us. Pricing is comparable with other thermal approaches, and our RF&S BU expertise in engineering has certainly been brought to the fore here in enabling us to connect with our customers at a wholly different level while developing their technology and their needs for more thermally efficient designs as we move forward. So these are just two aspects of our business. The photonic packaging is another area of high focus for us. But again, if anything in this presentation has shown any level of interest you'd like to take a deeper dive, I encourage you to reach out to us and we can organize a separate deep dive discussion on those subject matters. Thank you very much for your time this afternoon. I whizzed through this relatively quickly, and I apologize for that, but I think in the short time that we have, I hope I've sent a clear message of our business group's capabilities and how we want to align and assist our customers in their success moving forward. Thank you again.
Well, thank you, Mark. That is a lot of information to cover in a short amount of time. We appreciate you condensing it for us to meet the time requirements. But we do have a few minutes to answer some questions. If anyone has any questions, if you could just go ahead and unmute yourself, and we'll just take them verbally. And also, I launched another poll, so if you could participate in that, that would be helpful. First, to see if we can meet any needs that you may have. We do encourage you to reach out to your sales representatives in your territory with any questions. And we, as Mark said, we'd be happy to go into a deeper dive on any of these subjects. I will be sharing both the PDF of the presentation and the recording when it's available. So I'll send that out to everyone that participated. But if there aren't any questions, I'd like to thank Mark and Ryan for joining us and making this information available to everyone. And thank you for taking the time out of your day to participate in the seminar.